Right, welcome everyone. I'm so glad you came out to join me today. Who wishes there was more Python sessions at Ignite? For the benefit of everyone watching on the video, that was the entire room. Thanks, guys. I'm so looking forward to this session. This is going to be a whole lot of fun. Where has that gone? We actually have, despite what you might believe from the Microsoft of old, or even just from walking around the expo hall here at Ignite, we have a lot of stuff going on with Python at Microsoft right now. We're recognizing that it is one of the most critical cloud languages out there, and we are going as all in as we possibly can to make sure that your Python code is fully enabled on Azure throughout all our tooling. We want that to be a great experience, whether you're doing cloud, whether you're doing data science, whether you're into artificial intelligence, or just trying to script all of the servers that you're having to manage. We really want to make sure that you have a great time doing that. Since you've come to this session at Ignite, I suspect you already know why Python. But I'm going to go over that fairly quickly at the start. It might give you some handy numbers to take back in case you're in that position where you have to convince your management that it's OK to use Python. So I'll give you a few things that you can use for that. But then the rest is basically demos. I'm going to walk through Visual Studio Code, which you've likely heard of, but I'm going to walk through how you can make that a great editor for working with Python code, and indeed for working with Azure in the cloud. I'm going to go through Azure Pipelines, which is one component of Azure DevOps, recently renamed from VSTS or TFS. The new name is Azure DevOps. Azure Pipelines is the build CI/CD system, which has support for Python, and so I'm going to walk through how easy it is to set that up. Azure Notebooks is an online Jupyter notebook service, which if you're familiar with any of those terms, or if you're familiar with the Jupyter term, you should be getting excited now, but I'll show you that, especially for the data scientists in the room. How many data scientists do I have here? Who came in? Great, you're all in the same section, excellent. You're going to love that bit. And then I'll finish up with Visual Studio 2017, which is still our flagship IDE, still the best productivity environment for development, and I'm going to focus on interfacing between Python and C++ for when you have either scripting needs for your C++ app or performance needs for your Python app. So Stack Overflow runs a survey every year. And they ask a whole lot of questions, and a lot of them come up with interesting results. It tends to be one of the biggest samples of developers out there. And according to this year's survey, 2018, 38.8% of developers are using Python. The main areas, as I said, data science and machine learning, risen dramatically over the last few years. Web development is still big, always has been for a long time, but it's still a very prominent use for Python. Websites you may know of that use Python for web development: Instagram, YouTube, Washington Post, Reddit, written in Python, either partially or completely. And then there's the whole range of scripting, testing, automation uses that Python gets used for, and occasionally some weird kind of edge cases, like who has Dropbox installed on their laptop? That means you have an application written almost entirely in Python on your laptop that you never knew about, because it's so flexible it can get used in all of those situations. Told you it was quick, because you all came for the demos, right? So Visual Studio Code is our free cross-platform open source IDE, editor, heavyweight editor, with all the features that you want from an IDE without being totally overloaded and bombarded by all the stuff that you don't want. You open it up, you get into Python, you get IntelliSense, you get debugging, you get source control. It's all right there and integrated in a fast, lightweight package with an incredibly rich extension ecosystem. And that's one thing that I really want to emphasize. It's the extensions that make VS Code great. So the Python extension is a separate install. If you just fire up VS Code, you don't actually have Python support there. You go off and grab the extension. This is what brings in all the support for the language. It is currently the fastest growing language in Visual Studio Code. It's the most popular extension on the marketplace. And it's fully open source. It was originally created by Don Giamani, who now works at Microsoft full-time on this. And since he came on board, it has just accelerated in some really exciting ways. And there's literally thousands of other extensions that you'll probably be interested in. Key bindings. A lot of people will look at other editors and say, oh, but I use Vim. I can't possibly use something else. We have Vim key bindings. We have Emacs-friendly key bindings. Basically, you can make VS Code behave like whatever editor you're used to and get all the other benefits without having to lose that muscle memory. There's extensions helping forget. There's various extensions for Python libraries that are popular. Cloud stuff, deployment stuff, everything is there and available. Web helpers, integration with Chrome for debugging, Docker, and of course all the other languages are there as well. And there's a section that we just kind of call cool stuff right now because we don't really have a good name for it, except it's really, really cool. So if you've heard of LiveShare, got a demo of that coming along a little bit later because, hey, it turns out it works great for Python. So this is the marketplace. If you have not been there, marketplace.visualstudio.com/VS Code for the VS Code stuff. It also has the Visual Studio extensions, the Azure DevOps extensions, and it's linked in fairly closely with your subscriptions, so you can access all of the other things via that from here as well. If you're in VS Code, then it's actually just built in to the editor. You can bring up the marketplace, start searching directly in there, and just hit install to get those extensions. Okay, I promised demos. Because one of my favorite demos is to download and install the thing you're going to be demoing for the rest of the session right at the start, because I'm really, really brave. That's actually a lie. I'm just here to show you. Hey, big fat download button. We have other platforms as well. This is where you'll find the packages for various Mac and Linux distros. And then most of these also have the ability to download specific things for your platform on demand, so you don't usually get cut out of any special extensions. Once you've downloaded and installed that, on Windows at least, you can start running simply by typing code, because we'll install it into the path. And I'll use code dot to bring up my first demo, first sample. If you're on another platform, the installer can't automatically update your path. So we actually I have a screenshot of it later because I can't show it here. The thing you get most used to in VS Code is Control-Shift-P, Command-Shift-P, brings up the search for everything that I might want to do. And once you get that shortcut down, all the rest of it is, oh, I want to Python tests. And now you've found all the things that you might want to do with regards to Python and tests. So Control-Shift-P, Command-Shift-P, depending on your keyboard, is the one. If you're on a platform other than Windows, then you'll use this and you'll type install command in path, and that will bring up the modification for whatever shell you're using to make it so you can just type code. But the point is you can just type code and start it up in whatever folder of code you've got. This is not an interesting folder of code because I have two of my samples here. The next one will be a little bit more. But assuming I had a clean install, which, as I said, I'm not brave enough, the marketplace is down here on the left, and I would simply be typing Python, and that's going to come up with, here's the Python extension. And here are all the other extensions that have something to do with Python that you can use in VS Code. And here's some more extensions that have something to do with Python in VS Code. There's no shortage. If VS Code doesn't do something that you think it should, the marketplace is where you fix that. And as I said, everything from key bindings. Should I be really, really brave? No, I don't think so. And so you install the Python extension. It'll just make you reload the window. It's really quick. And now you've got Python support. And the way you get into Python support is you just make a new file. So I'm making one in the directory here. And demo.py. Because I called it .py, it gets a Python logo, and I'm in Python code. So I start typing, and I get completions for keywords. Anything available at the top level, just as you'd get for any other language. After the import statement, all the modules that I might want to import. And as I start going through these, they immediately show up in context, and I start getting completions from within the modules. So Absolutely nothing really surprising here for anyone used to a clever editor these days. If you're used to Notepad, then I assume your jaw is on the floor, which is why you're not applauding right now. But when you're used to Notepad, this is a step up. OK, so let me run through a little bit more Python code and show some of the how to make things run. Because this isn't just about editing. This is also about launching your code, debugging your code. So I'll do that import requests that I just did. And again, as I type through, we start seeing completions for everything that I might want to use in this context. What I'm actually doing here is I'm going to grab some of the Stack Overflow survey results, which I've already conveniently copy-pasted the URL there, and just show some of them. Now, it's the old results, because it turns out that the raw results in 2011 were around about 100 kilobytes, and the raw results for 2018 were considerably bigger. And this is a demo on stage, so I'm not downloading a big file. But I can run all of this by simply, in fact, I can just run the file from here, right-click and say Run Python File in Terminal. I can Control-Shift-P, run Python file. And simply by hitting that, it's going to activate my environment, and it's run. I only have one bit of output here, which is the application zip, the content type of that file. I can also select multiple lines and use the Shift-Enter shortcut. Which the nice thing about that is it's going to leave Python running at the end. So Python's largely built up around being a REPL, being an interactive environment. So quite often you'll want to execute some code and then interact with it again. So I can type more live code here. I can do all the things that I normally do in Python because I'm just in a Python terminal. I haven't had to Alt-Tab out to it, which is the big difference. I could go back into PowerShell and type mscripts Python, and now I'm in Python again. But we've integrated it all in here. We know which environment you're in. We know which copy of Python to run. We know which code to send to it. And so we've just saved you all of those manual steps from getting from your editor to the actual execution of the code. And just to keep typing a bit more to show that we do recognize far more clever things than you might expect. So request.get is one of those really complicated functions in Python that, depending on what parameters you give it, it's going to return a different type, and the kind of stuff that makes C# developers reach for object because you've just got no hope of casting it through anything sensible. Python handles that fine, and we actually recognize what it's come back as, or at least the union of what it's come back as, so we can do things like present you with completions for it. You'll see it says response in brackets. Response is the most common thing it comes back as, but if it came back as something somewhat incompatible, this would show you which objects it might have been on. So for those who know Python, you'll be following what I'm saying. For those who aren't Python users, you'll be going, what is wrong with Python there? It's weird. It can come back as different types of objects, and there's no real definition of saying, this is the object it definitely is when it comes back. And so we figure out all the things it could be, union them together, and try and give you as much information here in the completion list as we can so that you can make the right decision about which member to use. And I'm going to finish this up with just a cool demo, because this is a zip file that I'm downloading with the Stack Overflow results. But I haven't had to download it to a file on disk. If you look at this, I've gotten the request, so I have a response object in memory. I have two of them now. I have a response object in memory. I can show the content just by running that line, so it's around about 80 kilobytes. I can turn that into a readable buffer. So as far as Python's concerned, this is an in-memory file object that contains bytes, which I can now pass to a file API such as the zip file, which is going to load up the zip file, and it can show me the contents of the zip. I can extract things. I can extract them into memory. So I haven't even hit the disk yet. I haven't saved a file anywhere. This is just the kind of stuff that you can do quickly in Python, all in memory, very simple. This is why it's popular for sysadmin scripts. and just general pulling data together to make things easy. So this is what we just saw. As I said, if you're on macOS or Linux, Control-Shift-P or Command-Shift-P to update your path variable to include code. Otherwise, it really does feel like Notepad on some really good steroids. This is what we're about to look at now. I preempted a few of them. I'm going to open up code in a different directory. And this one has a bit more code going on. So that script that I started, I've now finished. And we have all the URLs for a range of years. We don't actually have 2018 worked into this yet, because I think the first time we did this demo, it was not yet released. But this is a bit more of a complex script. It's going to go through and download all of these, turn them into pandas data frames. So again, the data scientists in the room, we're using pandas now for loading this big table format, being able to process that easily. And we're just going to come up with summaries for the year. One of the things people run into very quickly on most operating systems, not always, but with Python, you can very easily have multiple copies of Python floating around your machine. There's also a system called virtual environments, which lets you create yet another copy of Python somewhere on your machine with a different set of packages installed. And choosing one of those is actually really important to make sure that you're getting the right completions in the editor, that when you hit run, it's going to run with the right version of Python. In VS Code, it always shows up in your status bar what your current one is, and if you click on that, it will bring up the full list of environments we've detected, and as you can see, I have a lot of them. And this is the place where you simply just come and select one and say, I actually want to run with that environment, and that's going to switch it over. So you can see the status bar has changed. We'll get a little progress indicator in a second as it figures out exactly what my code all means. But once that's done, I can run this code in the terminal. In fact, before that's even done. Apparently, I don't have pandas there. Now it's a real demo. Oh, okay. I will switch this one back to where it should have been, which is this one. And this one has pandas, thereby demonstrating that if you have the wrong environment set, you won't get the results you expect. So that's run through and processed all of the downloaded CSVs and generated this data file out of that. Linting is a really big thing in Python. Not everyone is familiar with the term linting, but it's basically static analysis. Syntax errors are kind of the obvious thing that you'd think of, where if you type some code that just doesn't make any sense, like this is not valid code, then you'd expect that to be all squiggled. And in fact, we do squiggle it sometimes in weird places. But in this case, that line is now marked. This file has an error in it. This is all done in VS Code through the use of existing tools. So the Python community has a variety of linters already out there, PyLint, Flake8, CodeFlakes. There's a variety of tools for doing this. And we just integrate them in. I should be able to configure linter. No. If I open up my VS Code settings, I don't even have PyLint configured. Here we go. So I've opened up my settings, and there's a whole range of linting settings for Python here. Flake8 and PyLint, MyPy is also supported for those familiar with that. These just all integrate in. They run on save automatically. So if you have style requirements, if you just want the the you have written something wrong help. So if I import something that's not a module, then we should get a warning show up for that saying you can't actually import that, and at that point it's not. But if I do it up here, where's my PyLint? There we go. Import, not a module. And you can see that's a PyLint error. So just in the background, every time you save, we'll rerun, we'll give you all that feedback. If you're thinking of just syntax errors, that's about 10% of what this does. These tools go much, much deeper in Python. You can avoid probably 90–95% of errors simply by running one of these tools. So we really try and encourage you to have it turned on. Everything from you misspelled a variable, which in Python you don't realize until you actually hit that line of code. These tools are going to find that automatically for you. Code snippets are another feature that we like, that I like a lot. I really love code snippets. These are my snippets that I was meant to be using for the demo before instead of typing everything by hand. But I also like typing stuff for demos. But code snippets are basically, here's a little section of code that I use all the time. Give me a short name for it, so I can type that name or at least pick it from the list. And then I can hit enter, and it's just going to insert that block of code. These are configurable. There's a JSON file that just has these in there. It's just, here's the block of code that I want when I type this thing. And they're a really easy way to continue configuring Visual Studio Code to work really well for whatever your workflow is. I showed run selection in terminal already. Refactoring is the last thing I want to show here, which I don't think I'm using this file again, so let's try it. Refactoring is, again, very popular in most languages. If you've been to any of the Roslyn talks, you've seen a lot of really cool refactorings. Python right now is somewhere a little bit behind that because we don't mostly have the type safety to be able to do it safely a lot of the time. So that's always the concern when you are refactoring things in Python. If you start calling a different function or returning something different, you really need everyone to be on board with that before you just go changing stuff. But there are a few that you can do fairly safely. So I should be able to do a rename symbol, and I can change this languages breakdown function to a breakdown languages. We don't do this ourselves. Again, Visual Studio Code is about bringing in the ecosystem into your editor, not about giving you, fully controlled, approved ways of doing things, if Microsoft says it's okay. So we rely on the rope library for this. And it's not currently installed, so I'm going to run off and install that. And this will be fairly quick, I hope. And so that's brought in the refactoring support. So now I do unfortunately have to go back and try it again. But this time we go off and run that tool. It's going to make the changes. And in a second when it's done, we'll reload the file, and it'll say breakdown languages instead of the other way around. There we go. So breakdown languages, and everywhere that we were calling that has also been updated. Again, this is not a trivial exercise in Python because there's a lot of ways you can end up with a reference to the same thing, even though the names aren't really the same name. And also the way you can have the same name in a lot of places when it's not really the same thing. So being able to do a rename like this is really useful, but it is a fairly complicated process compared to some other languages. So that's some of the scripting features you can do just as far as writing code. This demo is a bit more about, well, I'm going to continue with the same project. And I went and quit VS Code, so you get to see me run it again. Code dot for the current directory. And I'm back in here. I didn't save that breakdown languages in case you're looking at that and saying, he's pulling a fast one on us. This is different code. No, it's not. I just undid the rename. Even when the linter says your code is working, even when all the refactorings have been done properly and you think you've got everything aligned, there's still only one real way to know that your code works, and that's unit tests. And indeed, integration and user tests and all the things that go beyond that. But unit tests are certainly the starting point. Python knows this about itself. It's never really pretended to give you absolutely guaranteed code when you've simply written it. It's always said, you need to write tests as well. Your code is not complete until you have code that checks your code to make sure it's working properly. So these are a couple of tests written using the built-in unit test module. I cannot directly run this module. But if I do this, now I can run this file, and I didn't wait for the linter. Oh, and I didn't run it from the right directory. So I did. Okay. But no one really wants to do that, which is why it wasn't already in the demo and I tried to make it up on the fly. What you really want to do is have your editor be telling you, hey, here's some tests. They're currently failing. You should fix it. And so we have that as well. So the better way than fluffing about with ideas that I should have practiced and didn't practice is to start discovering tests. So the Python discover unit test command will either do the discovery or it will help you set it up for your project. This is a workspace setting, which means when I run it in this directory, it's going to be associated with this workspace. If I load up VS Code in a totally different place on my disk, so a different project, it can have different settings. And I'm not always forced into using the same framework. For this case, I'm going to use unit test framework because I know that's what it's using. The tests directory is the one that contains my tests. The files all start with test_star. You can also enter your own pattern here. And now it's configured, so we can see it's discovered tests. And now when I open this test file, I get all these cool little markings directly above the test. So I can run the entire class, run individual tests, and I'll come back to debugging them. But so now instead of typing random stuff in the console, I can just hit that button. And we get ticks for the successful test, we get crosses for the failed tests, and we get this nice little warning sign down the bottom that not everything went as we expected. If I click on that, then I can come up and find this view unit test output, which will show me what the problem was. And in this case, I'm not actually going to fix it. That's a little bit later on. But we do have a failing test here. There's nothing wrong with the syntax, nothing a linter would have found. It's just a simple calculation, didn't go the way it was meant to. And the only way we were going to find that is by having the tests. Let's say I want to dig a little more into why that isn't working. Who's familiar with debugging in other languages? Just for a quick survey. Most people. So who's familiar with printf debugging? OK. Who likes doing printf debugging? Good. You don't ever have to do that again. People do that a lot in Python because it seems like the easiest way. But it's no longer the easiest way. In Visual Studio Code, and in fact Visual Studio as well, we have support for debugging, which means you can set breakpoints throughout the code, start running. The code will stop when it hits the marker in the source code that you've put. So in this case, I can hover down the left margin. You'll see it goes, there's a little red dot under my cursor. When I click here, that turns into a hard red dot. That's a breakpoint. So now when I start running this code in the debugger, it's going to stop there and let me walk through one line at a time. And I can inspect everything that's going on. In this case, it's a test, so I'm just going to hit debug test. And this is going to run this one single test under the debugger. And you can see it stopped at this line. So I'm expecting it to fail, but I don't know why. And from here, I have a couple of step commands across the top here with their shortcuts, but I can step into and start actually working through my code to see why things are not coming out the way I expect. I can hover over variables and expand, see everything that's going on in there. I can index down into this and expand all the different elements, get a deeper look inside at what's going on in this data structure. And you'll see it steps exactly where the code is going. So we didn't go into this thing because that's not where the code is going. We keep stepping. This could take a while. I'll set another breakpoint after it and just continue. Now I can take that one away. And in this way, I can walk through line by line what my code is doing, inspecting the state at every point, and find out exactly what it is I need to fix. What I should have done instead of that breakpoint after the loop, though, is use run to cursor. And honestly, I didn't because I forgot the shortcut off the top of my head, and it turns out I don't have a shortcut configured on this one. So that's why. But instead of setting that breakpoint on this line, which is where I think the problem is, I can right-click on it, say run to cursor, and oh, there's my breakpoint. It's right in the middle of summary. I have not seen that before. And skip straight ahead to that line without having to set a breakpoint at all. So when you know there's a problem somewhere, it's really easy to skip further ahead. We also have this debug console, which is going to show the output of the process. So you don't actually lose the output that you would have been getting otherwise. You do get to see all of that as you step through and as different things get printed out. And you can use Shift F5 to stop. I'm still in the debug view because we've actually switched to this section here. I jump back up to the files and close that console. Now I'm back where I was. So that's a rough outline of debugging. There are entire sessions here on debugging. Not for Python, unfortunately, because we get one session. But there are entire sessions for debugging. We have online videos if you're interested in finding out more about the cool things you can do. I have a couple more coming up, though. Next, I want to do a little bit of web development. And in fact, I did not update the little 3-point thing here. We have a couple of options for web development. Well, we have a lot of options for web development in VS Code because it's a text editor. And so whatever web development you want to do, you can do. For Python, there is a lot of options, though. So there's a number of popular frameworks that are out there. Django, Flask, Bottle, Falcon is one that I'm hearing more about. The Pyramid is popular. A lot of choices for where to start. I'm not going to give you an answer on those. All I'm going to say is in this demo, I'm using Flask. Just as before, I'll open VS Code in this directory. This is a new one. And this is my Flask application. So I'm doing real web development here in about 3 lines of code per route. And yeah, to be fair, they're sending back static files. I could do a lot more in here if I wanted. These functions literally just return the content of the response. And if I want to return a status code, then I throw an error and put in the status code there. So it's a really straightforward, simple web framework. The static files that I'm returning, this data.json is the one that we calculated in the previous tool. And in fact, I've got the script here to process it again if I want. That comes out looking like this. Basically, we've taken the summary of all the content from the survey, and we want to render it in a chart. This index.html is going to use, where is it? It's going to use a plotting library whose name I'm not seeing right now, charts.js, for rendering this from the JSON file live. So it does have a request to get the data from my endpoint. So if I do just open this directly in a browser, which I should be able to do, it doesn't actually work because it needs to be running on a cloud server. It's trying to make a request to an endpoint that doesn't exist. And so I have the application that's going to respond to that. That API data route is handled here, and it'll return that JSON file. If I want to debug this, again, I set a breakpoint here. But when it comes to running it, we need to do something a little bit more clever than simply running the file. I've come to the debug view and I'm going to add configuration here. Now, configuration is basically a set of settings that determine how your project starts running. So you can do things like environment variables, working directory, command line arguments, and in fact for Python we have, should be popping up any second now, we have a big set of configurations for web development. So we've dropped into our launch.json file here, which has all of the settings. There's already settings for Django, there's settings for Flask, and I can add more configurations. There's also Node.js configurations, Docker configurations, so this is all just VS Code support for debugging to let you be using the framework that you're using, and we've got all the settings down for you. So in this case, I'm using Flask, so I'll switch this one to Python Flask, start debugging, and that's going to run a big complicated command line that you didn't have to figure out. And in the output, and it did not start. Oh, right, because I fixed that. Fixed it because, so that's how I'd change something. In this case, it's complaining that my Flask app variable has the wrong value in it, and in fact, it should be, what did I call it? And so now I have an actual web server running. Well, I have a development server running. The warning there is very real. If you do just run your actual web server on this, you're going to be in trouble. But what it's given me is a URL here that's telling me this is where my site's running. I can control-click this to open it in the browser. Because I'm debugging, I come back and hit the breakpoint immediately, which is expected. But again, from here, I can expand and see all the things that are set. If I was accessing the request object here, which I should be able to add that to watch. We should have, no, it's not imported. No. Again, don't make up demos as you go. If I continue running that, then the output is going to show, yes, we got the base route, and now we've got the API data as well. If I switch back, here's the actual rendered chart in literally just that few lines of code and the bit of data. But that's not all that useful for anyone who wants to be accessing it from outside of my machine, wants to be running it from outside of VS Code, wants to be running it on a real production quality server. So I'm going to step the game up a little bit and throw it up to Azure App Service. I already have a couple of extensions installed for this. So I have the Azure App Service extension is the main one. And that's going to pull down the Azure account. I've already done my sign-in, so I should be able to see my subscriptions under the Azure App Service group, but maybe not until I've published. Historically, publishing a Python project has been complicated, to say the least. It's taken a bit of work, a little bit of effort. We've simplified that. So now with this extension, I can grab this app directory, which is essentially my site, right-click it, and down the bottom is this deploy to web app. That, assuming I'm getting the distinct impression I'm not logged in anymore. Okay, it has loaded. Okay, let's try it again, now that it's loaded everything. Okay, it's going to walk me through setting up my environment. So I have an MSDN subscription here, which I'm going to use that one. I need to create a new web app because I don't have anywhere to deploy it yet. And I'll make up a name and hit enter. I get to choose an operating system. You can deploy to Windows or Linux, but if you choose Windows, Python is not going to work very well. If you choose Linux, it's going to work just fine. So I'll choose Linux. The Python 3.7 support is currently in preview, but we don't actually have any not in preview support for app service right now. And what that really means is I want you all to go and use this because we really want the feedback. We want people using it, breaking it, complaining about it, because now is the time when we can make the big drastic changes we need to improve it. So just because it says preview doesn't mean don't put your Python up there. It really means please put your Python up there because we want to find out where it's falling down currently. And as soon as I hit that, it has all the information it needs. It's creating my site for me. It's going to actually create all the resources I need and publish up the files. At the end, it should give me a URL that is going to let me jump to the site. And if anyone wants to also go to that site on your phones before I delete it in about 3 minutes, that's the URL. It just popped up there. So so-data.azurewebsites.net has been created. Hopefully, by the time you get your phone out and start going there, we will have finished deploying. But we are actually only copying up the Python files and the static files. So it's not a big, complicated install. We're not having to copy packages all over the place. It's ready to go. And so once that is completed, then I should get a nice big button that says open the real site. See what the output window says. I've probably been really unlucky and timed this along with every single other app service deployment demo, haven't I? If you've gone to the page and gotten an error message, you were quicker than I thought. OK, here we go. We've copied up the files. They finished deploying, which means in a second we'll get the URL. Deployment completed. I can hit Browse Website. And you'll see we get exactly the same graph as before, except this time it's on the real live internet, HTTPS enabled, all of the cool features that you get from app service. I can go in a couple of clicks and enable authentication using my Azure Active Directory tenant. And I've very easily just pushed up a site. If I need to push this again, I go back and I hit publish, and it will let me choose a default site to publish to, so I get down to 1 click to update this site. And it now appears in my Azure App Service view. So this SO data site, I can browse the files that are up there. I can look at the log files that are there. If I need to modify application settings, which appear as environment variables inside, then you can see that. We're not running behind that development server anymore. When you pushed it up, we put it behind a server called Gunicorn, which is developed by Heroku for all of their deployment stuff, but is free for anyone to use. So we're running you behind a proper server. And now that everyone's on their way there, I'm going to come here and show how easily you can delete a site by clicking delete and clicking yes. The one gotcha with app service, which some of you will probably know, is you actually get 2 resources generated. You get the service plan, which is the part that costs you money, and then the sites that fit inside the service plan, and they don't actually cost you themselves anything more. I don't know who came up with the idea that we make it easy to delete a site and not the service plan, because then we get to keep charging you money. But that was like one of the big gotchas going around for a while. This is going to tell you, hey, your service plan is empty. You don't have to be paying us money anymore. Should we get rid of that too? Yes, it can all go away. That site is now gone. If you're trying to go to the URL now, I'm sorry. That's web development. I covered app service. I left out Docker. There's a really cool Docker extension for VS Code as well that if you're deploying to basically anything else that can use Docker, you also have a similarly smooth experience for generating a Docker file. It's given to you so you can update whatever settings you need in that and then publish to various registries in just a few clicks. So I did leave that out this time. But that's another option that VS Code makes very available for you. Okay, the cool stuff. I'll come back to this one. So I mentioned this earlier, and it's been mentioned a lot. Live share is one of, in my opinion, one of the coolest things that we've brought to editors in a long, long time. I'm actually going to run VS Code twice here. No, except I'm not, because I need to run totally separate VS Code. Okay. Live share is an extension that lets you share your editor live with someone else, up to 5 people, in fact. Very easy to set up and use. Once you've installed the extension, you get, I can't actually see it there, you get a share button, which you normally associate with like, oh, post a link to Twitter or whatever. In this case, it's going to give you a link that you can share with someone else when it's allowed through your firewall. And it's already copied to the clipboard. I can then send that to someone else and let them log into my session. Normally when we do this demo, I have a colleague in the audience who I'll bring up on Skype and send them the link, and they'll log in and fix that broken test we were looking at earlier. I don't have one of those colleagues with me today, so I'm copying it to myself. And I'm going to jump over to this other window. Let me leave a little bit more room here so we can see what's going on. Oh, I can't do both. But I'm going to come over here and type join collaboration session. It already has the URL handy, which means if someone sent it to you and you've just hit copy out of the instant messenger window, then you just come here and join. The URL's already there. And when I do that, it's going to load up the session from the other person. So they'll get a little notification that I've joined. There we go. It will give you the option to get rid of them. But it will also give you the option to follow them. So I'm going to do this. When I click this as the number of people in here, I can choose the person who I want to follow. So I'm going to do that so we have something interesting going on the left-hand side. And now over here, as I move around, oh boy, that was jerky. Oh, you know what the problem is? I'm following the other person. I don't want to follow anything. Okay. This is not working as well today as it did yesterday. Okay. So I want to look at that test that was failing again. If I come over here, my test discovery has apparently been forgotten. So I'll discover these tests, and I'm going to debug that one that was broken again. And this time when it starts debugging, we also switch the debugger in the other instance. And now the person I'm sharing with has control over debugging as well. So it's not just watching. You may have noticed that I was editing over here as well, and the edits show up live. If I start doing self-dot, then I get completions for things that the other person would be getting, even if I don't have the libraries installed, even if I don't have the same version of Python on my machine. I'm getting literally a view into their instance. And because I control the debugger, I can do all my stepping and inspection and you'll see it's following along on the left-hand side. And at this point, I stepped over it, and the test has now failed, which was not very helpful at all. So I'm really just going to have to ask him to restart it again. But all I really want to do here is come in and fix that problem. And I happen to know where that problem is that was causing this to fail, because we don't calculate this total properly in all cases. So I'm going to be very magical and just use the snippet, and oh, look how quickly I typed all that code to fix it. And if I jump back to it over here, then you'll see, let me resize again. That code has been added in as well. Where is it? There. So that's the code that was just added. It's immediately shown up on the other side. I can come back, I can save that, and I can come back and run this test again. And I've been able to literally just call out to someone who's not in the same room as me, pair program with them briefly, whatever process we've had to go through to debug this and figure it out, and they've been able to add the fix for me. I haven't had to type a thing. They've just, all I've had to do is follow along. We've heard a lot of praise for this from people who teach. Mentors and teachers in particular have a great time with this because they can have their students follow along with real code on their own screen, particularly remote teaching, very popular. When I'm done, I can simply disconnect, leave the session, and I can close the S code. So that's LiveShare. That is freely available. It's still in preview, but again, preview means please use it, not try and avoid it until it's stable, because it's never going to get there if you don't use it for us. The other one that I want to show is a little bit more recent. It's called IntelliCode, so you may have seen some demos for this already. I'll get it by coming to the extensions marketplace. IntelliCode is how to find it. LiveShare is how to find the other one. I just have it disabled, so I'm going to enable that, which is like installing it, and it'll give me the button to reload the editor. So it's just got to close things down, bring it back up, make sure that my editor has that enabled. What IntelliCode does is it factors in some machine learning to the completions you get. So under normal circumstances, you start typing a name and then dot, and it shows up with every single possibility that might be there in alphabetical order because we're humans and we like alphabetical order. But most of the time, there's some real standouts, right? There's that one that you always keep going back for. And in fact, there's that one that everyone else in the world keeps going back for as well. And given that we have so many examples of this, of what people have written, we can run that through some machine learning models and come out with a system for determining what the most likely thing you're going to type is. So if I start typing some of this TensorFlow code and hit dot, normally I'd get abs at the top because ABS comes at the top. But we've looked at the context here, we've looked at what you've been doing and said, oh, you probably want variable most. If not, maybe random uniform, summary, one of the other ones. It doesn't even matter what I type in this because I'm not even going to run it. And we do this in context as well. So as you go through more code, we're not just looking at the one line or the one thing you just typed. It's going to look at all the code up to that point and say, oh, well, if you're up to this point, if you started doing placeholders now, you're probably going to do more placeholders and not the variable that you did before. If you're up to, you've done the reduced sum, then tf train, you're going to want one of the optimizers. And so we'll offer you the things that make sense in the context that you're in, rather than what we normally do for IntelliSense, which is give you everything that we know is there. So this one is, again, so this sample didn't work because I didn't type all the rest of them. So if I do that, now global variable initializer is there because it turns out when you skip half the demo, it breaks the demo as well. So we're actually using the previous state to figure out what comes next. Right now, this is based on one kind of big global data set that's come out of, I assume, millions of GitHub repositories because they're public and we can get them all. At some point in the future, you're going to get the option to enable this on your code. So the patterns that show up regularly in your own repositories, we'll have the ability to analyze those, assuming you give us permission to look at your code and analyze it, and give you recommendations that make sense for your code base, for your developers. So again, the way to get to those, ext-install LiveShare, ext-install IntelliCode, or if you just end up in that marketplace and search, then you'll be able to find those and grab them and use them. All right, time to switch gear. We're off Visual Studio Code now and onto Azure Pipelines, Azure DevOps. As I said earlier, Azure DevOps is the renamed Visual Studio Team Services. It's also the renamed TFS, so if you're using either of those, then you'll be using Azure DevOps now. It is our cloud-powered build, test, and deploy system. Unless you've got the on-site version, if you've got the on-prem version, which is Azure DevOps Server, I believe, then you have your own cloud-powered one and not our big cloud-powered one. We offer builds running on Linux, Mac OS, Windows, and you can use Docker in all of these, so if you have containerized builds, you can do those too. Open source projects, which essentially means you said this project can be public, get 10 free parallel jobs. By default, you get 1, and you can pay for more parallelism. But open source projects get 10 unlimited minutes free jobs. There's a number of features that fall under Azure DevOps. The ones that I believe are of most interest to Python developers, Azure Pipelines is the build CI. I'm going to walk through that one. Azure Repos is essentially Git repositories, and you can have unlimited private, unlimited public repositories in here. Azure Boards is our work tracking. So if you've ever thought to yourself, I really need all the complexity and power that the Windows team uses for tracking their millions of bugs, you can have it now, because these are all our internal systems that we've been using for years available for you to use as well. And Azure Artifacts is really cool. That is your own private NuGet, NPM, Maven, and very soon Python feeds for packages. So you can publish packages to your own private feed, share that within your builds, within your company, and let people access those. So my plan is to very, very quickly build a pipeline for my Python project that's going to run tests and then publish a package. I have a little less time than I expected at this point, so I might end up going so quickly it doesn't work, but we'll try anyway. So I have my Ignite 2018 project here, which has, each of these can have its own overview, have its own boards, repos, pipelines, and artifacts. I'm going to go straight to pipelines to set up a build, and it's just going to tell me there's no build right now. So I'll start a pipeline. There are currently 2 ways of working through this. This is one of the preview features right now for setting up YAML-based pipelines, which is a code file that describes how it's all going to work and stick that in your code repository. This is really popular with open source projects. Most of the other CI providers default to this and only allow this. And so we have an easy walkthrough with some really good templates to get you going on either a GitHub repository or Azure Repos. I'm going to go through to the visual designer this time. This is the slightly older UI, so they'll converge eventually. But you can see here we have a wider range of sources for your code, including arbitrary Git URL, which means if you don't even have proper authentication to it, you can still grab the code from it. In my case, I'm getting it from my GitHub. My project is called Deck, which Pythonistas can go and have a bit of a laugh at the joke there if you like, but that is not actually relevant now. And I'm going to start with an empty job. There's a big range of templates here. There's even a Python package template, but for a number of reasons, it's not the right one for this project. So these all help you get started, but I'll just start with an empty job. Now, a pipeline comes with the concept of jobs. And jobs can run in parallel or have dependencies on each other, but that's one of the unit of work, basically. And jobs typically have different tasks. So I'm going to make one of these my run tests job and make another one that is publish build. I already have a good idea of what I need in here, so I'll add a use Python task, which is going to let me choose a version of Python to run against. And then I just want command line. Now, despite the name of this, these are cross-platform tasks. So this will be a bash command on Linux and Mac. This will be a CMD command on Windows. Because I am running tests, I want to publish my test results. So I'll add that as well. And for the build, I'm also going to use Python. And I want 2 commands for this one. OK, The most interesting thing about this is I don't just want to run the tests once, I want to run it on all the versions of Python I support. So at first glance, you may be like, okay, I need lots of jobs for this, but you don't actually, because we have this parallelism section for multi-configuration. For some reason, this maximum number of agents is not just 99. I don't know, it should be. But what I can put in here is a variable name. So my version variable is going to be what's called a multiplier. So when I set this variable for the build, I can put in 2.7, 3.5, 3.6, 3.7. These are the versions I support. And I'm going to go over and tick this box that says make it settable at queue time. Now instead of the 3.x here, I'm going to use that version property. And that's just going to pick a different version of Python for the 4 times that it runs this job and pass in a different variable. So I can very easily do it in multiple versions at once. This script is going to install PyTest, and that, I believe, is all. And then run PyTest on deck-tests.py. I'm doing this from memory. Normally, I'd go back and look at the repository, see what's going on. And it's going to put the test results into a JUnit XML file. The location it puts that is the one that this is going to be picking it up from. We default to JUnit, and so by using the standard formats that are already out there, we'll get nice integration into the rest of DevOps. I'm just going to save and queue it now. I don't actually have to fill in that second task. Actually, I will set a dependency here. So the other thing that you can do with jobs is give them dependencies on each other. So this one is only going to run when the run tests job has completed and it's succeeded. If it fails, it's not going to move on to the next step. And it's going to combine it all. So this one, you'll see when I start it running, we're going to run the tests 4 times. There's only going to be one job for publishing the build. And just for fun, let's change this queue. I should have shown this. Pipeline option has an agent pool. It defaults to hosted Windows with Visual Studio 2017. We have Mac builds, we have Ubuntu builds, and we also have the opportunity here to put in private build queues. So by doing that, you can have your own machines that will run builds. Anyway, you can run .NET Core, you can run the build agent for this, which means if you've got a laptop under the desk, you can run builds on it. If you've got a Raspberry Pi, you can run builds on it. As long as it has an internet connection, it will happily run these builds. So you can see I have 4 jobs going in parallel here. These are the 4 separate tests, and they've got the different marking on them to show which is which. They're all going to run their steps, run their tests, upload their results, and you'll see the final result come out here. 2.7 tests failed, and I can dive into the logs and come down to where the error message is, and it turns out that, oh, we just don't actually support Python 2.7 with this library. 3.6 and 3.7 are fine. 3.5 is also going to fail because we don't support that one either. And the end result is going to be that we never run the publish build step because some of the preceding jobs failed. So you can see this was skipped. If I hover over it, it shows the condition succeeded, which was false. So simply changing it to Ubuntu is not actually going to fix that, but I will take out, in fact, I'll do that. Stay here. But I will take out those unnecessary versions next time I run it so that we will get to success. This time, oh, and the other one I missed here, use secure file. Download secure file. Okay. In this publishing one, what I'm going to have to do now is install a couple of tools that I need. So I'm going to install Flit, which is what I'm using to build, and Twine so I can upload. And then I'm going to Flit build, and if that succeeds, then I'm going to do Twine, upload, dist star, config equals, come back to that, builds. So I snuck in this download secure file. What I have in here is my server configuration. So the files that I want to upload, I need the authentication for that server. I have those in a secure file in my build library. So no one can actually download this and look at the content, but it can be brought down as part of the build in a way that makes sure it automatically gets cleaned up regardless of the result. And the only people who can access it are those who have actually set up the build definition. I'll give it a name here, so this becomes the variable with the path. And that's going to be my configuration file. When I queue the build this time, I can modify that version and take out 2 of the builds because they're the ones that are not going to succeed. And queue it up again. You can see this time there's only the 2 jobs there for run tests. You can multiply this in many different ways. You can multiply across all sorts of requirements, all sorts of properties. If you configure this as a YAML file, then you can do nice sets of variables in it. There's a few more tricks to doing it through the UI for that. But when I am ready to turn this into a YAML file, I can come up here and go to the pipeline stage, and there's a View YAML button. This is actually on every single item in the list, and we'll just bring up the YAML version, which typically needs a little bit of cleanup because there's some things that are not one-to-one mappings between the UI editor and the YAML file right now. But it is most of the work that I would need to do to embed this build definition in my repository. And all the tests succeeded this time, so we're going to run the build job. And I will preload this next page while that's going. And so just to show you the feed here, Azure Artifacts is one package repository with multiple ways of accessing the packages in it. So I'm uploading a Python package now, which means we'll have a Python package show up, but it's essentially the one feed. So when I say connect, I get a list of all the different tools that I can use with it. Ignore that it says PyPI right now, it's going to say Python. But this is where I can generate my credentials. So when I hit this button, I get that login information that was in my secure file before. And assuming everything succeeded here, which it did not. Oh, okay. So I cannot do that because in my previous test run of this demo, I uploaded a package with the same version and then deleted it, hoping that I could redo the demo. Guess what? You can't do that. So I'd need to rev the version number to get the update here. I'm not going to do that right now because time constraints. So that's Azure DevOps and the Python integration, which is really quite nice. Keeping your configuration as code as YAML in your repository, really good idea. It lets you track changes to everything, lets you see who's changed things. But being able to do it in the interactive designer is a good way to iterate while you figure out what you need to be doing. There's parallel jobs. You can run multiple jobs in different operating systems, containers, and the Python support in Azure Artifacts is coming very soon. There's a private preview, so if you're interested in that, I would go up to their booth and ask them about it. But otherwise, that will be becoming available very soon. Azure Notebooks, I mentioned earlier. I'm going to skip the demo on this one for the sake of time. Azure Notebooks is instant compute in the cloud. We have a website. It's notebooks.azure.com. If you go there, you log in with O365 account or your organizational account or anything that works as a Microsoft account. It's free to log in, and you get a full install of Anaconda, which is one of the big Python distros. You get a number of languages to work with, and you just get this nice interactive workspace where you can type your code and see the results immediately. So it's like being in the Python interactive window in Visual Studio or Visual Studio Code, but it's all HTML-based, a lot of extensions, a lot of nice rendering. This is kind of the world that a lot of data scientists are living in these days. So if you have a data science team at your company, then they're either using Jupyter for this or they want to be. And this is a way that you can give them a simple URL and say, just log in here and not actually have to worry about installing things on your own machines. So the demo I did not do covered these things. But that's the URL, notebooks.azure.com. Free for use. Again, it has some preview markings in places, which means please use it. And there are ways to provide feedback to the team about what you need, what you'd like to see. Okay, let me move on to Visual Studio. Visual Studio has been around for a long time, and you may be very tempted to say that Python developers now have Visual Studio Code. Why would they want Visual Studio? And there's a couple of reasons. Visual Studio really does have the complete IDE experience. VS Code's kind of let's walk through the steps of filling out this wizard to configure stuff is done in full in Visual Studio. You get dialogues, you get wizards, you get all sorts of additional windows for doing things. The IntelliSense is, of course, at this point, it's exactly the same as what's in VS Code, so you don't lose or necessarily gain anything there. But the cross-language integration is one of the core features of Visual Studio that just really isn't available elsewhere. Being able to use Python and C++ together, which is the demo I hope to get to, is really powerful, and it's best experienced in Visual Studio. I also put multi-window up there because a lot of people's biggest thing that they dislike about Visual Studio Code is not being able to put windows wherever they want. Guess what? In Visual Studio, you can. You may regret it, but at least you've got the option to arrange your windows however you want and dock them all over the place. So, my demo is scripting a 3D dancing ogre, whose name is Sinbad. So Ogre 3D is an open source game engine, which I have taken one of their samples, so none of this is my actual creativity. I didn't even design the dance. But what I've done is I've taken it and I'm actually controlling what he's doing with a Python script. So if I Alt-Tab out back into Visual Studio, I have a Python file up here with the script, which is currently just dance and stand. And I have some things that I can enable in here. And at least for the C++ developers in the room, you should be fairly impressed with what I just did, because I just changed the code and hit one key in the app, and now it's doing something different. I didn't have to recompile, I didn't have to relink, I didn't have to do all of this stuff. It didn't take minutes to get back to a running app with different settings. So the power here is when you have a C++ app where the business logic changes often, or you just want some way for the users to interact and have more power over what it's doing, embedding Python in that gives you a great opportunity to expose that in a way that does not require users to become developers. I did not start debugging when I did this, but I'm going to restart this under the debugger to show some of how the integration works. So now I'm in the debugger, and as you'd probably be used to in Visual Studio, you can set a breakpoint and it's going to hit somewhere. I'm going to set that breakpoint in my Python file, and if I can direct your attention to the bottom right, you'll see the call stack window, which has a mix of Python and C++ call frames. This is some of the integration that I mentioned. This ability to jump between C++ and Python. Jump out here and I can see, I hope, some of the C++ variables, but also to be in the Python land and be able to see the Python variables is really, really powerful. Really smooths out the experience in a way that you just don't actually get with any other tools right now. I can keep stepping through this and freeze everything. And I'm going to declare that demo failed right now because I have 48 seconds. So the things you didn't get to see, but there is a video of this online. So if you search for, I don't actually know exactly what the search term is, but you can find a demo of this. I'll track it down and tweet it out later on. You can find a full demo of this online where I walk through a lot more of it, spend a good 20 minutes on it. But one of the most powerful reasons to be in Visual Studio is for working with multiple languages at the same time altogether. So even though you may walk around Ignite, you may look at the subject selection and think we're not doing a lot with Python, the truth is we are. We have a lot of Python work going on. We have a lot of SDKs coming out, a lot of libraries, a lot of machine learning tools, a lot of developer tools. This was a quick tour around the developer tools that are available. This is the overview. If you want to see more and track with what we're doing, aka.ms/pythonblog, which I see people are taking photos, so I haven't advanced yet. But this is the URL. If you follow our blog here, you'll get all the announcements, everything that we come out with. Thank you all for being here. Really appreciate it. If you'd like to chat more about it, I will be at the languages booth in the expo hall for the rest of the day. Thank you very much.